Hi, I'm Candice Morey. My colleagues Claudia von Bastian, Ralitsa, Kostova, Evie Vergauwe, and I have new evidence that assuming a single dimensional resource can explain temporary storage and working memory. I'll walk you through it. We want to know whether to include separate, distinct stores for verbal and visuospatial information in models of working memory. This has been tested many times using complex span tasks, where participants are given an item to remember, then a stimulus to judge, then another memory item, and so on. Researchers can manipulate the nature of the memory items and the judgment stimuli, making combinations within domains, like verbal memoranda with verbal judgments, or cross domains, like verbal memoranda with spatial judgments. If there are distinct verbal and visuospatial stores, then recall should be worse when the disruptive judgment stimuli and memoranda share the same domain. Past results have been inconclusive but flexibly interpreted to support contradicting claims about storage and working memory. We use state trace experimental design and analysis to avoid this ambiguity. So we designed 4 adaptive complex span procedures aiming to isolate any between version differences to maintenance processes specifically. Our participants completed 3 sessions for a total of 576 experimental trials. Tasks crossed either spatial or non-word memoranda with identical judgment stimuli that required either a rhyme or symmetry decision. Sets of irregular grids and non-words were updated across sessions to prevent familiarity. Starting span lengths, those were 2, 4, and 6, increased per session when participants performed well to ensure a wide spread of performance from easy to hard levels. Serial recall in both tasks occurred via mouse selection. These hypothetical state trace graphs plot verbal recall on the x-axis against spatial recall on the y-axis for each span length, those are the points, and under each processing task, those are the 2 lines. If there are distinct verbal and visuospatial stores, at some levels of performance, the verbal and visuospatial processing tasks should differentially affect recall, with verbal processing hurting verbal recall more than visuospatial processing, and vice versa. This needn't occur at all performance levels to observe 2 distinct traces, as in panel A, whose points cannot be connected by a single line. Compare this with panel B, in which all of the points can be connected with a single line. If we observe a pattern like that in panel B, then our results can be explained by assuming a single latent storage resource. If we observe 2 distinct traces, like in panel A, then we need to presume more than 1 latent resource supported recall performance. Here are per participant state trace plots, with the average state trace in the lower right-hand corner. These plots show very clear and consistent patterns, suggesting that the rhyme and symmetry judgments affected verbal and spatial recall very similarly throughout the performance space. We applied the MHAT model developed by Cox and Kalish, which provides a value quantifying how well a single factor solution fits the data. Our MHAT values were consistently approaching 1, which suggests that our results are unambiguously explained by assuming that only 1 latent factor is needed to support verbal and spatial serial recall in these complex span tasks. Our materials and preprint are available in the Open Science Framework. We're grateful for funding from the British Academy.